The last time I was with you, we learned about the power rule for derivatives. Today we're going to get some more practice using the power rule for derivatives and take a look at some of the varying ways you can be asked to find a derivative. In this first problem, they ask us to find the slope of the line tangent to this curve. Slope of the line tangent is the derivative. It's one of the meanings of derivative. So essentially, we are asked to find g prime, given g. So the first thing that we need to do is make our function g in the form where we can apply the power rule. So I need to make sure every term is a number times x to a power. So right now, 2x to the 11th is already a number times x to a power. So I don't need to manipulate that. I do need to manipulate this one though. This is going to be negative 12x to the, okay, the third stays in the exponent. The fourth root, that 4 goes to the denominator of the exponent. So this is x to the 3/4. To change 6 over x to the 5th to a number times x to a power, I keep the 6 on top. It's not moving, it stays on top. All I'm doing is I'm moving the x to the top. So it'll be x to the negative 5th power. And then we have this term. We'll have the negative 14 x to the, we're moving the x to the top, so it will have a negative exponent, and the exponent is 2 over 7. 2 over 7, like that. So now g is in the form where we can apply the power rule for derivatives. Let me remind you that when we find g prime, we are taking the derivative of both sides with respect to x. And the notation for doing that is this. We're taking the derivative of both sides with respect to x. When we do that, we do get g prime of x. Alright, power rule. The power times the coefficient. Keep your x, reduce your power by 1. 11 minus 1 is 10. Next term, 3/4 times negative 12. 3/4 times negative 12. If you need to come off to the side and multiply that out, negative 12 times 3 over 4. The 4 and the 12 reduce, and this leaves us a negative 9. So feel free to come off to the side and simplify fractions, do what you need to over there. But this is going to be a minus 9. X to the, we are reducing 3/4 by 1. So 3/4 minus 1. 1 can be written as 4 over 4. 3/4 minus 4/4 is negative 1/4. Okay, next term. Negative 5 times positive 6 will be a negative 30. Keep your x, reduce your power by 1. Negative 5 minus 1. Negative 5 minus 1 is negative 6. Be careful with that. So often I see students, they want 5 to go down, so they make it a 4, but they keep the negative and they call that a negative 4. Negative 5 minus 1 is not negative 4. It's negative 6. Be careful with that. Okay, negative 2/7 times a negative 14. Negative 2/7 times negative 14. It's going to be a positive. 7 goes into 14 twice, so this is going to be a positive 4. So plus 4 x to the, okay, we are reducing negative 2/7 by 1. So negative 2/7 minus 7/7 is negative 9/7. So don't get lazy. Go ahead and do the math. You will get very good at subtracting and adding 1 to fractions after you take calculus. All right. So This is our derivative, and there's nothing wrong with this expression. Nothing wrong at all. In a multiple choice answer, that very well might be one of the choices. However, if it's not one of the choices, they have moved these exponents with the negative these terms with the negative exponent, they have moved that part of it back to the denominator. So 22x to the 10th would remain the same. This would be written as negative 9 over x to the 1/4. Note that the 9 remains in the numerator. The 9 does not travel with the x to the denominator. It has to stay. Okay? Just like here, the x was on top, and it stayed on top when we brought the x to the 5th to the top. Okay? So this will be negative 30 divided by x to the 6th, and this will be a 4 divided by x to the 9/7. So one of those would be the multiple choice answer that would be correct. Okay, number 2. Let's consider this function. What is the slope of the line tangent to f at the point when x is 1/3? So this is the derivative. That's the derivative. And after we find the derivative of f, we are going to plug in 1/3 for x. But first things first, let's find the derivative of f. So I'm going to take my f, and I need to write it in a form where we can apply the derivative, the power rule for derivatives. So I see one little term in the denominator, so I'm going to divide, and I'm going to do the quick divide by taking every term on top and dividing it by x. So all I'm doing right now is rewriting f. 6x cubed divided by x is 6x squared. Negative 8x divided by x is negative 8. 3 divided by x is 3x to the negative 1. We want that to be in the form a number times x to a power. It has to be in that form before we can apply the power rule for derivatives. So now that it is in that form, I'm going to take the derivative of both sides, reiterating what I'm doing. I am taking the derivative of both sides with respect to x. And I will get f prime of x is equal to, okay, exponent times the coefficient, keep your x, reduce your power by 1. We'll just have a 1 as our exponent, which we usually do not write. The derivative of a constant is 0, so that piece will be 0. And then negative 1 times 3 will be a negative 3, x to the negative 2. All right, nothing wrong with this expression. However, we're about to plug in a value, so I definitely will help myself by moving this x to the negative 2 to the denominator of that term to make that 2 divided by x squared. Okay? Now I'm going to plug in 1/3 for x. I need to say what I'm doing. So one way to say that is f prime at 1/3 is equal to, so now I am plugging, I forgot my x right there. Now I am plugging in 1/3 for x. So I'm plugging in 1/3 for that x and for this x. Okay, and to reduce that for a multiple choice answer, 12 goes into 3 4 times, and this will be 2 divided by 1/9. If I multiply top and bottom by 9 on that term, I get 4 minus 18 over 1, which is 4 minus 18, or negative 14. So that would be the multiple choice answer. Okay. Alrighty. Number 3 here. Find the value or values of x at which the graph of y has a horizontal tangent line. Okay, a horizontal tangent line is a tangent line with a slope of 0. Tangent line slope is 0. Okay, so we can find the derivative, that will be the slope of the tangent line, and set it equal to 0. Solve for x to answer this question. So I'm going to take y and write it in a form where I can find the derivative. I have one little term in the denominator, so this is another quick divide problem. Okay, 5x squared divided by x squared is just 5. Negative 4x divided by x squared is negative 4, x to the negative 1. Negative 2 divided by x squared is negative 2, x to the negative 2. Okay, so now I made y in a form where I can apply the power rule, because every term is a number times x to a power. So I am taking the derivative of each side. We get dy dx, or you can call that y prime if you prefer, either way, because they mean the same thing. The derivative of any number is a 0. Negative 1 times negative 4 is 4. Keep your x, reduce your power by 1. Negative 1 minus 1 is negative 2. Negative 2, the power times the coefficient, will be a positive 4, x to the. Keep your x, subtract 1 from your power, so negative 3. Okay? I'm going to again help myself by saying this is 4 over x squared plus 4 over x cubed. And we want that slope, this is the slope of the tangent line, we want that slope to be 0, so I'm going to set this equal to 0. I'm setting that equal to 0. I had a college professor who would do that every time he set something equal to a value, and it stuck with me, and I like it a lot, so I keep on doing that. Whenever I set something equal to a number, I will write that little word set above that equal sign. Okay, now we are back in the fall where we are solving this equation. So in class I would ask, what do we do to find x here? So what I would think to do is to multiply both sides, get a different color here, multiply both sides by the denominator. You know me, I don't like fractions, so I do what it takes to get rid of any fraction immediately, or as soon as I can. So if I multiply both sides by x cubed, that will get rid of these two denominators. I will be left with 4x. From the first term, I'll be left with a 4x. From the next term, I'll just be left with a 4. And 0 times x cubed is 0. So now we get something that's very easy. Once you do that, it's very easy to solve for x. So the value of x at which this graph has a horizontal tangent line is x is equal to negative 1. Okay. Number 4, let's consider this curve. At what value of x is the slope of the tangent line to the curve equal to 2? We want the slope of the line tangent to the curve to equal 2. So I'm going to find the derivative and set it equal to 2. Okay? So first things first, I need to write this in a form where I can apply the power rule. So y is equal to, I'm going to rewrite this as 1/3 x to the 4th, because something divided by 3 is the same as 1/3 times that something. Minus 3/2 x to the 6th plus 2x plus 25. Now every term is in the form a number times x to a power, so we can use the power rule for derivatives. by taking the derivative of both sides with respect to x. So we will have dy dx is equal to the power times the coefficient, keep your x, reduce your power by 1, the power times the coefficient, 3 halves, negative 3 halves times 6, the 6 and the 2 reduce, and this is negative 9. So negative 9x to the 5th. Okay. The derivative of 2x is 2. The derivative of a constant is 0. So that is my derivative. We want the slope of the tangent line to be 2, so I'm going to set this equal to 2 and solve for x. When I subtract 2 from both sides, those are gone. That's the first thing I notice about this equation. Okay, and now I would probably multiply both sides by 3 to get rid of that little fraction. So I would have 4x cubed, because these 3's cancel out, minus 27x to the 5th is equal to 0. To solve this for x, I'm going to factor out an x cubed. So I get that. So I have two things being multiplied to get a 0. So either x cubed is 0 or 4 minus 27x squared is 0. Well, if x cubed is 0, that means x has to be a 0. If this is 0, I'm going to solve this for x. So I'm going to subtract the 4 on both sides. Oops. Divide both sides by 27. And now square root both sides. When we square root, don't forget our plus or minus. So I get x is equal to plus and minus. I would probably just write that as 2 over the square root of 27 and call it a day. We know that we could take a 9 out of that and reduce this a little bit, but if it was multiple choice question, I would see if I could do if I needed to. Otherwise, I would just leave it like this. I'm going to bring over this x is equal to 0. Those are my answers. So there are 3 values of x at which the slope of the line tangent to this curve is equal to 2. Okay, number 5. We are asked to write an equation of the tangent line to the graph of this function when x is 3. So think about that. This is some curve. In fact, I know what this curve looks like, right? This is a parabola pointing up. It's a parabola pointing up, and when x is 3, it has a line tangent to it, right? We want to write the equation of that tangent line. This is a very common question that is asked of us in calculus to do. Write an equation of a tangent line. And every time I say, what do we need to write the equation of any line? We need a point and we need a slope. Point and slope. If we can get a point and a slope, then we can write the equation of the tangent line using this formula, this equation that you learned back in Algebra 1. Y minus the y value of the point is equal to the slope times x minus the x value of the point. Okay? Our equation will have this x and this y in it. So we first need to find the slope. Well, we can find the point. Let's find the point first. For the point, we usually do find the point first. So for the point, what is the point on this curve when x is 3? Well, how do you get that point? You just plug in 3 for x and get the y value. So we are finding g at 3 to get the point. This will be 2 times 9, which is 18, minus 4 times 3, it's negative 12, and then plus 5. 6 plus 5 is 11. So the point is 3, 11. Okay? Now for the slope. Well, for the slope, I need to find the derivative because slope of the tangent line is the derivative. So here's my g of x. And I'm going to come in and take the derivative of both sides with respect to x. I just realized that I'm writing everything in red, and I usually don't, but that's okay. All right, so we get g prime of x is equal to, little power rule here, so power times the coefficient. Keep your x, reduce your power by 1. The derivative of negative 4x is just negative 4. The derivative of 5 is 0, so this is the derivative. That is the slope at any value of x. We need to find the slope exactly when x is 3. So g prime of 3 will be 12 minus 4, which is 8. Once we get those, we can write the equation of the tangent line using this formula. Y minus the y value of your point is equal to the slope times x minus the x value of your point. This is the equation of the tangent line, and we leave it just like that, unless it's a multiple choice question and they have it in a different form. Okay? If we needed to, we could distribute that 8 through these parentheses and add 11 to both sides. Yeah? And if we needed to, but only if we're needed to, because it said, the problem said to write an equation, and this is an equation. And on AP, this is normally what they expect you to do. Okay. Number 6. Write an equation of the tangent line to the graph of this function when x is 16. So anytime we're asked to write an equation of a tangent line, I think point and slope. Point and slope. Once I get the point and slope, I use the point-slope form of the equation of a line. So for the point, that will be f at the x value that we're asked to find. So I'll have 18 divided by the 4th root of 16. The 4th root of 16 is 2. So my point is 16.9. Now for the slope. Well, I'm going to write down what f of x is, but I'm going to write f of x in the form where I can apply the power rule. So I'm going to bring the x to the top to be with the 18. It will be 18x to the negative 1/4 because the 4th root of x has the power 1/4. Now I can use the power rule for derivatives. Again, I am taking the derivative of both sides with respect to x. F prime of x will be negative 1/4 times 18. I'm going to come off to the side. Negative 1/4 times 18. All right. 18 and the 4 reduced to 2 and 9. So this is going to be negative 9 over 2. That's negative 9 over 2 x to the, I'm reducing the power by 1. Negative 1/4 minus 1 is negative 5 over 4. Okay? And since I am about to plug in a number for x, I'm going to help myself by moving this power back to the denominator. The 2 is already in the denominator, so I'm going to put the x with that 2 and give it a positive power. So that is f prime of x, and now I need f prime at 16. So I am putting 16 in for x. Okay? How do we handle this? Take the root first. The fourth root of 16 is 2, and then 2 to the fifth power is 32. Let me say that again. The fourth root of 16 is 2. 2 to the fifth is 32. So this becomes negative 9 divided by 2 times 32, which is negative 9 over 64. So that is the slope when x is the slope of the tangent line to the curve when x is 16. So my equation will be y minus the y coordinate of our point is equal to the slope times x minus the x coordinate of my point. And that is the equation of the tangent line to this graph when x is 16. Okay, number 7. The polynomial. This polynomial has a relative extremum at the point when x is equal to what? Relative extremum. We had that term back in the fall. A relative extremum of a polynomial is a relative min or a relative max, and that is when the polynomial has a hump. All right? So that is when we have a hump. This is a cubic, so a cubic, actually this is a cubic with a positive lead coefficient, so this cubic looks like that. Or it could look like this. Okay? A relative max would be at this point, a relative min would be at this point. At both of those points, at both of those places, the slope of the tangent line is 0. So if we are asked to find the x coordinates of the relative min and max of this polynomial, we can find the derivative and set it equal to 0, because the slope at each of these places is 0. Okay, so that's what we are going to do. I'm going to take my equation and take the derivative of both sides with respect to x, get dy dx is equal to power rule time, so 3 times 4 is 12. Keep your x, reduce your power by 1. 2 times 2 is positive 4. Keep your x, reduce your power by 1. The derivative of 1 is 0. So that's the derivative. To find these spots, I'm going to set that derivative equal to 0 and solve for x. Okay, I can take out a 4x from both pieces. It will leave me with a 3x plus 1. That means from this one, x is 0. From this one, x is a negative 1/3. So this curve does indeed look like this. There's not just a little flat spot. It does indeed look like this. These are the two x coordinates of the relative min and max. So x is equal to negative 1/3 must be the location of a relative max. X is equal to 0 must be the location of a relative min. Those are my x values. We have a whole unit in calculus devoted to this sort of conversation. Okay? So that was just a little peek at it. All right. Another way that you can be asked questions about derivatives is using the graph of a function. So let's take a look. Let's say this is the graph of f here. This is the graph of f, and it asks what values of x satisfy f prime of x is equal to 0. Well, f prime of x is the slope of the tangent line And so we are asked, what values of x are there here where the slope of the tangent line is 0, right? Well, I see 3 places where the slope would be 0. The slope is 0 when x is 0, the slope is 0 when x is n, and the slope is 0 when x is p. So I would say x is equal to 0, n, and p. Okay? Number 9. On what intervals is f prime less than 0? The slope of the tangent line is negative. If the slope is less than 0, that means the slope must be negative, right? So they're asking us on what intervals is the slope of the tangent line negative. Well, if I envision tangent lines, I'm going to start when x is as far left as I can get it. The tangent line here has a positive slope. The tangent line here has a positive slope, positive slope, positive slope. Here the slope is 0, and then on this little segment right here, the slope of the tangent line is negative. So the slope of the tangent line will be negative from x equals 0 to x equals n. Then the slope becomes positive again, and then negative after p. So on what intervals is the slope of the tangent line negative? From 0 to n, and when x is greater than p. This would be inequality notation. Of course, you can use interval notation as well, 0 to n, and p to infinity. Either one of those notations is fine. Okay, on what intervals is the slope of the tangent line positive? Well, it will be on those other intervals. So from negative infinity to 0, and from n to p. So I might write that in inequality notation. That would be x is less than 0 and x is between n and p. In interval notation, it would be written negative infinity to 0 and n to p, like that. Okay. On which of the following intervals is f greater than 0 and f prime less than 0? Well, f is greater than 0 when the curve that I'm looking at is above the x-axis. I want to write that down. Curve is above the x-axis. Okay? F prime is less than 0 when the slope of the tangent line is negative. So I'm going to look for intervals where the curve is above the x-axis and the slope of the tangent line is negative. Well, this curve is above the x-axis only right here. And on that piece, the slope of the tangent line is negative only here. So from p to 2. So x is between p and 2. All right. On which of the following intervals is f less than 0? That would be when the curve that I'm looking at, the graph of f, is below the x-axis. And f prime is greater than 0. That means the slope of the tangent line is positive. Okay? Well, the curve is below the x-axis for most of this graph, all but this section here. So on the part where the curve is below the x-axis, the slope is negative. Here the slope is positive. Here the slope is negative. Here the slope is positive. Here the slope is negative. So I need from 0 to n and from 2 to infinity. So I might write that as 0 to n and x is greater than 2. That would be inequality notation. In interval notation, you could write 0 to n and 2 to infinity. So you can always either, it's up to you, inequality notation or interval notation, know them both because they are both used on the AP exam. But you can, if it's a free response question like this, you can choose which form you want to write your answer in. So that is a little bit of another way to using the power rule for derivatives to answer a variety of types of questions.